All right, I'm going to do this FRQ. So I maybe recommend people trying it on their own, um, and then just checking your answer and checking to see if you were thinking about it the right way or a right way. So okay, so here let's get into this. Okay, so here we'll just read it and then I'll go back into the paragraph and highlight certain things that you need to kind of pick out of this. Okay, so they say sculptor. Get this. So sculptor uses a constant volume of modeling clay to form a cylinder with a large height and a relatively small radius. So like a some kind of a cylinder, yeah, like a really thin bar, kind of cylindrical bar. Okay, clay is molded in such a way that the height of the clay increases as the radius decreases, but it retains its cylindrical shape. At time t equals c, so just some random time, some specific point in time, the height of the clay is 8 inches, the radius is 3 inches, and the radius of the clay is decreasing at a rate of a ½ inch per minute. Okay, so let's highlight all this and we'll use this stuff in different parts. Okay, so one thing they say, the first thing they say is that the sculptor uses a constant volume. So they're using a constant, a certain amount of clay, and they're not taking away from it or adding to it. They're just changing the shape of it. So that's significant, that first thing. So here, so constant volume of modeling clay. Okay, so first thing is, this means that dV dt equals 0. Okay, it's a constant volume. That means the volume's not changing. So dV dt is 0, not changing. Okay. Okay, that was weird that it chose that color. Okay, so next thing. So they say here the clay is molded in such a way that the height increases, the radius decreases, but okay. At time t equals c, a certain point in time, the height is 8 inches. Okay, so the height 8 inches. So we'll say h equals 8. Okay, and then they say the radius of the clay is 3 inches. Say r equals 3. Okay, and the radius is decreasing at a rate of a ½ inch per minute. So radius decreasing at that rate, 1/2 inch per minute. Okay, that means that dr dt, the rate of change of the radius, is decreasing, so it's negative and negative ½. Okay, so notice I'm just going through this paragraph and just taking all these little phrases or little facts that they give and putting them into math symbols like this. Either what the variable equals at that moment. All this is all this analysis is like at a certain moment in time. Okay, so we'll see. We'll use kind of out of those 4 things, we'll use different ones in different parts. So at time t equals c for part A, they say at what rate is the area of the circular cross-section of the clay decreasing with respect to time? Show your computations that lead to your answer. Indicate units of measure. Okay, so definitely let's draw a picture. Actually, not definitely, but let's draw a picture. Sometimes we don't really need it necessarily for this one, but it'd be good to know just what it looks like. Okay, so it should look something like that. Oops. Okay, that's weird. Alright, that's very weird. Okay, so here, sorry. Ugh. Sorry. Why is it doing that? Okay. Alright, so time t equals, okay, what's the rate, at what rate is the area of the circular cross-section of the clay decreasing with respect to time. Okay, so what they're really looking for here, and let's write that down, is they're really looking for the rate that the area of that cross-section, so you have this circular cross-section of the clay, and we want to know how is that area decreasing. So we know that this is going to end up being negative since they tell us it's decreasing, but we want to know the rate that it's decreasing. So we want to know dA dt. Okay, so first thing is to after we draw our picture, is label any quantities that are changing. Here, if we're just kind of focusing on the cross section, the only really thing that we're going to be focusing on is the radius, so we'll label it R. Okay, and then we need a formula that involves all the variables. So variables are definitely area, because we need to get dA dt, and so there's only one formula for area of a circle, pretty much, pi r squared. Okay, so next thing is take derivative with respect to time. So derivative of area with respect to time is just dA dt. Okay, and then derivative of the right hand side, so I'll write 2 pi r times dr dt. Okay, and really like this 2r dr dt, not the pi, is derivative of r squared. R squared is 2r dr dt. The dr dt comes from the chain rule, taking the derivative of the inside. Okay, so now we need dA dt. Things that we'll look to see, do we have r and dr dt? And yeah, so that's why it was nice that we put it into mass symbols, all the stuff that they gave, because now we can see it super clear that we'll just substitute these values. Okay, so this is 2 pi, they tell us the radius is 3 at this moment, and then the dr dt is negative a half. Okay, and then we just simplify that, so that'll be negative 3 pi. Alright, and then units. So this is dA dt, so we need the units of the area divided by the units of the time. So the distance is in inches, so area will be in square inches. And then the time is in minutes. So this will be minutes. Okay. So that's the answer to part A. Okay, so next one. Okay, time t equals c, at what rate is the height of the clay increasing with respect to time? Okay, show the computations that lead to your answer, indicate units of measure, and then they give the volume of a cylinder, which they will in the AP test for certain formulas. Okay, so first thing is to figure out what we're looking for. They say, at what rate is the height of the clay increasing? Okay, and that's with respect to time. Okay, so they're really asking for dH dt. How fast is the height increasing with respect to time? So put it over there, that'll remind us what we're looking for. Okay, so we need an equation that involves height. So in this case, we have this volume formula that involves height. Okay, so let's make a picture first. Okay, so that's our cylinder, and then we'll label anything that's changing, we'll label it with a variable. So this radius will be changing and this height will be changing. So we'll assign that r. Whoops. Make this radius r and this height h. Okay, so let's use our formula for volume that we'll take the derivative of. So volume is pi r squared h. Okay, so volume's not changing. right? They tell us in the problem that the volume is constant, but let's just take derivative and then we'll worry about all that stuff later. Okay, so take a derivative, so derivative v is dv dt. And then we'll do product rule. So I'll consider this to be one term in the product rule and this to be the other function in the product rule. Okay, so derivative pi r squared is 2 pi r dr dt, and that's times the height, and then plus, and then pi r squared, the first function, times derivative h with respect to time is dh dt. Okay, so we're looking for dh dt. All the unknowns are r and h, and then dr dt and dv dt. So we have to make sure we have all that. Okay, so let's go up to the top and see. Oh my god. Let's go up to the top and see what we have. Okay, so notice dv dt, since the volume's not changing, that's 0. Substitute that. And then, oops, and then 2 pi, and then r was 3 up there. dr dt is negative a half. And then h is 8. So just looking at all this kind of information up here. Pi, and then r, 3r squared, and then dh dt. Okay, so we had everything we needed, and now we can just solve for dh dt. Okay, so this will simplify to be negative 24 pi. This is negative 24 pi, but we'll bring it over to the other side to make it 24 pi. And then that's 9 pi dh dt. Okay, and then just divide both sides by 9 pi. So dh dt is 24 pi over 9 pi. Pi's cancel, and then that'll end up being 8/3. Okay, units. So units of h divided by units of time. So units of height, really any distance, in this case is inches, and the time was minutes. Okay, last one. Okay, so last one they say write an expression for the rate of change of the radius of the clay with respect to the height of the clay. Okay, in terms of h, height h, and radius r. Okay, so this one's a little different. Okay, they say write an expression for the rate of change of the radius with respect to the height. So what they're really asking for is rate of change of the radius with respect to the height. So dr dh in this case, not dt in the bottom. Okay, so we're going to be end up taking the derivative of we'll end up taking derivative volume, you know, because it's got the r in it that we want. Yeah, I think that'll be the best thing. Yeah, okay. So let's do that. This will be a little different. Oops. Okay, so we'll start out with our volume. Okay, so now we need to take derivative of this, but with respect to height. Okay, so first we'll take derivative volume with respect to height, just dv dh. Okay, and then derivative, we'll make this one term in the product rule. So derivative of pi r squared with respect to height is 2 pi r times dr dh. Okay, so that's what we're looking for. and then times the height, and then plus, and then now we'll do this times derivative of h, but derivative of h with respect to h, since that's what we're taking derivative of with respect to. Derivative of h with respect to h is 1. So this ends up just being pi r squared. Okay, and you can kind of see, like, if I'll do this kind of off to the side, if you do derivative of h with respect to h, you can see like you get the same thing in the top and bottom. And this notation you can actually like divide, if you get the same thing in the top and bottom, that does equal 1. So okay, so now so dv dt isn't changing, so dv dh isn't changing. So as the height changes, the volume doesn't change. Really just the volume doesn't change at all. So this is just going to be 0. Okay, and then here, we'll write this. I'm going to write the h there. Okay, and then we want to solve for this dr dh. Is that right? Just making sure. Yeah, dr dh. Okay, so definitely we'll just subtract this over to the other side and then divide by that. So here, let's write that. dh equals. Okay, so this will get subtracted to the other side. That'll be on top. And then we'll divide by this 2 pi rh. Alright, and we'll simplify it. The r's, r squared and the r's cancel, so just 1 r on top. The pi's cancel. So you're left with negative. You'll have an r in the top, and then a 2h in the bottom. Okay, and that should be an h. Okay, and so units are units of radius divided by units of height, and you could say inches per inch. And a lot of times, sometimes you can combine the, cancel out those units, but it's really inches of radius divided by inches of height. So same units, but it's units of different types of things. So yeah, a lot of times you don't want them to cancel out because you lose meaning. Okay, so that's all these. Hopefully that helps. And really, like the way we did this, there's a couple weird things, like taking derivative with respect to a different variable than time. Usually it'll be time that you'll take derivative with respect to for these types, but it doesn't have to be. So this one's a little weird, taking derivative with respect to h. Yeah, so whatever you take derivative with respect to, that's like our x, like of what we're used to. Normally we take derivative with respect to x, and then when you take derivative of x, that's 1, But if you take derivative of y with respect to x, that's dy dx. And that kind of works that way with any variable. So okay, that's